These notes are over the distance formula. The reason we're going into the distance formula next is because it's actually kind of the same thing as the Pythagorean theorem. So you can have a right triangle and let's say that we're trying to find the distance between 2 points, right? So we have a graph here. There's a point here and there's a point over here. And we want to know what the distance is between these. You can take any 2 points and then add 2 more lines to it and make it a right triangle. And then use the Pythagorean theorem to find that missing side. So if we have the Pythagorean theorem, a squared plus b squared equals c squared, and we want to solve this for c, which c would be the distance between these 2 points, which we call d here, we could take the square root of both sides, and we would get that c equals the square root of a squared plus b squared. Now we want to replace a with this right here and b with this right here, because that is what is going to give us the difference between those 2 points. So we're subtracting the x's and subtracting the y's to give us that distance there. And so these are related because we make a triangle to find the distance between 2 points. So you can use the distance formula or the Pythagorean theorem for these. The distance formula might be easier for you because it just has the x1 and x2, but that way if you ever get confused, you can kind of think about it that way as well. Because if we have this picture over here, right, we can count just like 1, 2, 3, 4, 5, and then we can count this way, 1, 2, 3, 4, 5, 6, 7, 8, and then we have 8 squared and 5 squared, right? And then this would be our hypotenuse squared. And so doing the x1 minus x2 and y2 minus y1 is the same thing as us, like, say, counting those squares there. Okay, so let's look here. Let's try this first example, and we're just going to use the formula for this one. So distance equals square root. I'll make that pretty big. You have a lot to write underneath it. And if you need to, you can label these as like x1, y1, x2, y2. So you know which ones to write in. So we're going to have 4 minus 5 squared plus 1 minus 2 squared. So 4 minus 5 is going to be negative 1. So negative 1 squared plus 1 minus 2, which is negative 1 squared. And so we're going to have the square root of 1 plus 1, which is the square root of 2. We can leave it as that or estimate it as 1.4. Let's try this next one. We'll use the formula again for this one. So the distance is the square root. And we'll have 6 minus negative 5. Remember, you have to do minus negative 5. It's not just 6 minus 5. And that is squared plus negative 4 minus negative 3 squared. So 6 minus negative 5 is going to give me 11 squared plus, and then we have negative 4 minus negative 3, which is going to give me negative 1 squared. So we'll have 11 squared, which is 121 plus 1. So the distance will be the square root of 122, which is approximately 11.04, or actually be 0.5. Okay, next we have a picture. So You could use the distance formula for this one, and you just need to know what the points are. So one of our points is going to be -2, 0. My other point is going to be over 2, down 5, so 2, -5. And then you could use the formula. But for this one, I'm going to have us create a triangle here so we can visualize this. And instead, we're going to use the Pythagorean theorem on this one. So we have 1, 2, 3, 4, 5 on this side, and then 1, 2, 3, 4, 5 on this side. And so we're going to have 5 squared plus 5 squared equals, and then this missing side, we want to know what the distance is x squared. So we'll have 25 plus 25 equals x squared, which is 50 equals x squared. And the square root of 50 is approximately 7.1. Now you'd get the same answer if you used the distance formula. You would just have that distance, this is still on this top one over here, by the way. We would just have that the distance is the square root, and we could do -5 minus 0 squared plus 2 minus -2 squared oh, that's actually 3, sorry. Three minus -2. So our distance would be -5 squared plus 5 squared, which is again going to be the square root of 25 plus 25, which is the square root of 50. And so they do end up being exactly the same. Okay, this one, you must go to the museum and then go to the hospital after school. How far will you travel? So you're starting here at school. We're going to the museum, and then we're going to the hospital. How far will you travel? So we want to figure out what is the distance here, and then what is the distance here. So I'm going to erase this, and we're going to start with just one of the distances first. So we'll start with the distance from the school and then to the museum. Redraw that. Okay. It looks like the point for the school is kind of in the center there. And so we'll have to count by a half of a square. And so we're going to have 1, 2, 3.5 on the bottom, and then 1, 2.5 on the side. And we want to figure out what is our distance here. So we'll have 2.5 squared plus 3.5 squared equals x squared. Or again, you can use the points and then use the distance formula. So 2.5 squared plus 3.5 squared is 18.5. And the square root of that is approximately 4.3. So that's from the school to the museum. Okay, now I'm going to erase this, and we are going to find the other one, which is from the museum to the hospital. So for this one, we don't even have to create a triangle because we can just count the squares. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to add 8 to this. So our final answer would be 12.3. Okay, so example 3. We want to find the distance of AD, the slope of DC, the distance of AB, and then the slope of AD. So let's start with the first one, finding the distance between A and D. As we can see, for the distance between A and D, it is just a straight line. So you could use the distance formula, or for this one, you can just count. If it's a slanted line, you're going to have to create a triangle. So for this one, I see that A is starting at 0, and then D goes all the way up to 7, so the distance is just 7. Now we want to figure out what the slope is of DC. So you need to remember how to find slope. So slope can also be called the rate of change. So we want to know our change from D to C. Remember, slope is rise over run. So you have to go up and down first and then left or right. So from D to C, we go down 2 and then over 1, 2, 3, 4, 5, 6, 7, 8. So 2 over 8. And since we went down 2, it would be negative, and we went right 8, so that would be positive. So negative 2 over 8, which is negative 1/4. Now the distance between A and B. This one we're going to have to create a right triangle for. So I'm going to create this right triangle here, and we could do the sides of distance of 2 and then 8. Or we could use the distance formula. So A would be negative, is that 4, 0. Point B is over 4, negative 2. So let's use the distance formula for this one. So we'll have negative 2 minus 0 squared plus, I did the y's first. Doesn't really matter the order because you're just adding them in the end. We will do the x's first, so 4 minus negative 4 squared plus negative 2 minus 0 squared. So my distance is going to be the square root, so 4 minus negative 4 will be 8. 8 squared is 64, plus negative 2 minus 0 is still just negative 2. Negative 2 squared is going to be a positive 4. And then we'll have 64 plus 4, which is 68. So the square root of 68 is approximately 8.2. And we want to find the slope of AD. So we rise how many? 7, but we don't go over any. And so we have 7 divided by 0. We can't divide by 0, right? So it's undefined. We don't have a slope here. Undefined.